Hello everybody, welcome to Dr.K.Liu Maths channel. And here is the question about Oxford Mathematics Admission Test 2023. And this question is about the trigonometry. Here given the function cosine 2 times x plus 30 degrees. What is the maximum value of this? We use the basic knowledge to present the maximum of this function. Has cosine, the value of cosine x is lie between -1 and 1, and when plus 30 degrees, it means translate to the left by 30 degrees. But the value still -1 and 1, and also when times 2, it means reduce along x-axis by 2, but the value also between 1 and -1, and therefore the maximum is equal to 1. And for the second question, and find the maximum and minimum of this function. I've first let theta equal to 2x plus 30 degree, and then this can be written as cosine theta times 1 minus cosine theta, and multiply into, we have a quadratic function. And by using the method of computing square, we can get this answer. Cosine theta minus 1 over 2 bracket square minus plus 1 over 4. And then start from the cosine theta, which is lie between -1 and 1, and then minus 1 over 2, the value is lie between -3 over 2 and 1 over 2, and then take square the value, and the minimum, the least value is 0, and the maximum value is lie over 4, and then plus take multiply by minus sign. The value will change sign. The maximum will become 0, and the minimum become -1, lie over 4. And then add 1 over 2 both hand side. We have the maximum become 1 over 4, and the minimum is -2. So in this question, question 2, the maximum value is equal to 1 over 4. Yes. Okay, for the third question, I rewrite. Okay, it is easy question. I rewrite this question as cosine 2x time 2x plus 30, and then 1 over cosine 2x plus 30, and all the power to 3. Okay, it has we present this, the maximum of this is equal to 1 over 4. Therefore, the maximum of this expression is equal to 1 over 4 to the power to the 5, which is equal to 1 over 2024. Okay, for the last part, it's not easy for it's not directly for the calculation, and also I have to change the domain. I write down the question first. Cosine sine. Okay. 1 minus cosine 3x minus 60 and square and all for power to 4. And on the other hand is 3 minus cosine 150 minus 3x to the power 8. And then I first change this into sine square 3x minus 60 to the power 8. And for this one, has the cosine minus theta is equal to cosine theta, I change to cosine 150 minus 3x to 3x minus 150 to the power 8. And then cosine sine 90 minus theta is equal to cosine theta. I use this formula, change this to be cosine. Cosine power to 8, 90 degree minus 3x plus 60. Finally, I change all the stuff into the form of cosine. And luckily, the angle is also equal to 150 minus 3x. Which is basically same as this one. And we basically I only change the sign here inside the cosine 3x minus 150. And then for the convenience, I let theta equal to 3x minus 150. And therefore the equation can be expressed as cosine power to 8 theta 3 minus cosine theta power to 8. And take out the power to 8. And now consider cosine theta times 3 minus cosine theta. Expand this and becomes minus cosine square theta plus 3 cosine theta. By using the competing square, we can have the form of cosine theta minus 2 to the power 2 at minus plus 9 over 4. And we start from this one, cosine. As the cosine value is lie between minus 1 and 1, and then cosine theta minus 3 over 2 lie between minus 5 over 2 and minus 1 over 2. Take square. The least value, not 0, but 1 over 4. And the greatest value is 25 over 4. And then take minus sign, change the inequality sign. The greatest value becomes minus 1 over 4, and then plus 9 over 4 as the format here. Then the greatest value is equal to 2, and the least value is minus 4. finally, I take power to act to all the sides of the inequality, and I have to change the sign here. Therefore, the maximum is equal to -4 to the power 8. Yes, this is the final answer. 65536. Great. Okay, that is the end of the presentation, and finally please subscribe my channel, and this is the observer mathematical admission test. Thank you. Bye bye.